In MCQ number 3, we are investigating of which of the following value at the bottom represents that of the element of beryllium, and this is based off the second, third, and fourth ionization energy of each of the four elements. As you can see at the bottom, we have antimony, arsenic, selenium, as well as beryllium. So based off this, you can actually just take a look. I will always advise students to write out their electronic configuration to see at each of the different ionization energy from which of the subshell are we trying to remove the electrons. Now this is mostly because ionization energy is determined by two factors. It's considered to be inversely proportionate towards your screening effect, meaning the higher the screening effect, the lower the ionization energy, or is proportional towards the nuclear charge, or which can be simply put that the screening effect is determined by the number of electron shell, and the nuclear charge is determined by the number of protons. Anyway, we know that these elements reside in group 15 as well as group 16, so let's just write them out first. So in group 15 here, we actually have your arsenic as well as your antimony. And on the case for group 16, we're looking at selenium as well as beryllium. So let's just remind ourselves again, we are interested in trying to find out which of the energy is actually representing beryllium. So we are also going to put in the period number. Arsenic, we're residing at period number 4, and for your antimony, we're residing in period number 5, and this could be say the same for selenium at period 4 and beryllium as well at period number 5. So arsenic configuration over here, first we should be looking at a 4s2 4p3, just writing out the valence shell. And for the case of antimony, which is just one period below, it will be at a 5s2 and a 5p3. So writing down at the first IE, right, we're moving from 4p, 5p. At the second IE, we're still moving from 4p and 5p. Third IE, we're moving at 4p, 5p. And lastly, for the case of the fourth IE, we're moving from 4s and we are removing from 5s. So you can see that we are actually migrating one shell inwards, and by migrating one shell inwards, that means that there is a lower screening effect, and this will manifest itself by showing us that there will be a much significant ionization energy increment. It should be having a little bit of a spike because you went from a 5p, 4p into a 5s, 4s respectively. Now for the case of selenium as well as beryllium, let's just write out their configuration. So selenium over here, we're going to have it as your 4s2, 4p4. Beryllium 5s2, 5p4. Similarly, at the first IE, getting from 5p, 4p, second IE, getting from 5p, 4p. At the third IE, still getting from 4p. And for beryllium, we're getting from 5p. And at the fourth IE, this is going to be 4p. And this is going to be at 5p. You can see that we are not removing from the inner shell. We are not removing from the inner shell. So for the fourth IE, we should not be looking at a very massive spike when it jumps from the third to the fourth IE, at least for the case of group 16 element, irregardless is it selenium or is it beryllium. So based on this, coming back to the diagram, you can see that there is definitely a huge jump in A from third IE to the fourth IE, suggesting that this is likely to be a group 15 element ionization energy series. And you can also see another huge spike in C itself, jumping from the third IE to the fourth IE. This is showing it at as well, likely that is removing from an inner subshell, likely to be seen for group 15 for third to fourth IE, because we're moving from 5p to 5s or moving from 4p to 4s. So automatically, I will be eliminating A as well as C. So the plausible answer here is going to be at B and D. You can see that there is a very gentle increment from the third IE to the fourth IE, from the third IE to the fourth IE. So the final determination on how do we actually then determine whether it's a B or D to represent beryllium comes from the fact of understanding that screening effect itself is inversely proportional towards ionization energy. And since beryllium is at a greater period, it has additional screening effect. Naturally speaking, the ionization energy should have been much lower in comparison towards any of the element that is a period. So with that, I'm obliged to say that the answer I'm looking over here is going to be the case for B, because generally the values are much lower in each of the respective category. You can see that it's at 1800 as compared to 2080. It's at 3010 compared to 3090 at third IE. It is at 3680 as compared to 4140 for the case of the fourth IE, making the answer definitely to be at B, to reflect the increase in screening effect of beryllium by being at a bottom period.